Hi, what's up, people? I don't feel like the lighting is okay, so let me change the lighting. Hey, what's up, great people? So today I want us to have a quick talk where I'm going basically to talk about the science behind black holes. If you are not into astrophysics or astrology, you might find a very difficult problem in trying to understand what is a black hole. But for those people who do really understand what I'm talking about, we can continue on. Even if you're a beginner into these kind of topics, I want you to bear with me because I'm going to explain. That is the reason I'm making this video. So imagine an object so dense that not even light can escape from it. That is the black hole. It has a great gravity. I don't want to go biased, but you have to understand that the gravity is so great that light cannot escape. So not even sound, no reflection, no second chance. Once you cross a certain boundary, you are not going to come back. And that is what you have to understand. When I think about black holes, I think about addiction. But addiction has a benefit because you can come out of addiction, but it is just like a black hole. The loop keeps on coming back. Even if it takes 20 years, you are going to test that alcohol again. You are going to test that weed again. You are going to do the same thing that you did. Even if it is poverty, like it is just a black hole, you can never escape. So, when we're talking about black holes, people think that it is science fiction. This is not science fiction. This is a black hole, and it is real. It happens in the world. People are so fixated on textbooks and explanations that they were given in textbooks, and they rely on their teachers so much. They rely on the institution so much. They even can't use their own eyes and ears and look at the world and explore, because we are in the cosmos already. Everything is a universe. Like if we talk about atoms, then me looking at this hand, you shouldn't be worried like, okay, what is he doing? What the fuck is he doing? Motherfuckers, I'm discovering. I'm looking at an atom. So today we are going to break down the real science behind black holes, how they form and how they grow, what happens near them, and why they may hold the deepest secrets in the universe. The ocean doesn't hold the deepest secrets, the black holes do. So the first question you might be asking me, okay, Evans, you're talking about black holes. What is really a black hole? I'll give you a simple and definite definition of what is a black hole. It is just a region of space-time. What is space-time? We exist in space. Everything you see here, this is gaseous. What are gases made of? They are made of atoms. What is an atom made of? They're made of protons and neutrons and electrons. The space between electrons and the nucleus, that is the space. It is called space. And moving from the space, time cannot escape. Space cannot exist without time. Because if you have to move from one place to another, you are going to move through space, and you have to move through time. Am I making myself clear? So that is what is called space-time. So it is a region of space-time where gravity becomes so strong that nothing, not even light, can escape. That is why the beginning of the video told you that it is all about gravity, and I equate it to addiction. The idea becomes directly from Albert Einstein's theory, the general relativity. If you really understand physics, you already know what I'm talking about. According to the general relativity, gravity is not a force. It is a traditional, in the traditional sense that we thought from the Newtonian concepts. It is the curvature of space-time caused by mass and energy. When we try to look at the universe, we talk about energy, space-time, energy, space-time, and matter. That is what creates the universe. So, if you compress enough mass into a small enough space, the space-time curves infinitely. This results in a black hole. At the center of something called a singularity is just a point where density becomes infinite, and the laws of physics, as we know them, they break down, they stop working. We cannot comprehend what happens there because our little mind cannot picture. They will fracture. But I'm hoping that as we are moving into quantum computing, and we are trying to understand, and we are building very powerful machines, we will be able to decode these entire things and come to really understand deeply what reality is and what is life. Surrounding it is the event horizon. Surrounding, let's say a singularity is a black point somewhere. This is where this is where the density. What is density? What is density? You see, you have to understand these concepts in order for you to try and understand what I'm trying to say here today. If you don't really get in here, endo chukue physics textbook, go through a physics textbook so that you unaelewa, angalia mechanics, thermodynamics, just peruse tu uta get what I'm trying to say. Because most people will never understand this, because they will never even reach. Most people will never even watch this video. So you see, the surrounding the singularity is the event horizon. This is the boundary beyond which escape becomes impossible. Let's say if it is a black hole ni kitu kubwa tuseme kama ball. Then in the center kuna singularity. This is where the gravity become big, and the density is like if it is this pencil, let's say this phone, it is compressed down until it becomes small. You cannot see it anymore. So the mass has been compressed, and in the middle the density, it is infinite. So think of the event horizon as the ultimate point of no return. Addiction. Question number two. How do black holes form? Let me explain this so that you can understand. How do black holes form? Most black holes are born from dying stars. When a massive star like the sun, or even much larger than our sun, runs out of the nuclear fuel. We know that the sun burns of hydrogen and nitrogen at the same time. That's the great mystery. We haven't yet get enough data in order to understand how it works. So it can only no longer fight against its own gravity. This is when the sun stops working like the fuel. It's over. So it has to, because it cannot stand against its own gravity, so it compresses its mass. The core collapses violently. This collapse triggers a massive explosion, which is called a supernova. If you have heard people talk about supernovas or in science fiction, then this is what they mean. If the remaining core is heavy enough, gravity keeps on crashing it inward until it forms a black hole. So, for comparison, our sun will never become a black hole. Why? Okay, the star needs to be roughly 20 times more massive than the sun in order to collapse into a black hole. This is called stellar black holes, but there are even bigger ones. At the center of almost every galaxy lies a supermassive black hole. How many black holes do we have in our universe? Google it down and comment down below in the comment section. So, at the center of our own galaxy, we live in the Milky Way galaxy. Sagittarius A has a mass of about, that is the sun, 4 million suns. That is Sagittarius. Sagittarius is Sagittarius A plus. I think that is the name of the black hole. and it has a mass of 4.4 million suns. 4 million suns, because when a supernova has collapsed, and the density is infinity, and we have created a singularity, and there's an event horizon. The same thing is happening to AI. As we are moving on forward, these great companies are working together. They are creating an environment possible to escape from, and the same thing is happening to wealth and inequality in our. This is one of the great concepts. If you get to understand it, you are going to understand how really the world works. Not only in how physics works, but how economy, psychology, how money works. How they grew after a Big Bang remains one of the greatest open questions in astrophysics, because these things are very big. When you say that we are able to fit 4 million suns into a black hole, that is something which you have to really work on and try to understand in the future. We are going to try to understand that in the future. But okay, what happens near a black hole? Contrary to popular belief, black holes do not roam the universe vacuuming everything. If the sun were magically replaced by a black hole of equal mass, the Earth will continue orbiting normally. The gravitational pull, or at that distance, because let's say we are talking about 100 to 200 million light years away. So not light years, but I'm saying that okay, let's say 2 light years. 2 light years. The gravity, the Earth will still be orbiting the sun, because in order for the gravity of a black hole, you must be close into that event horizon in order for you to be unable to escape. But if you are far enough, nothing will affect you, because it is the same thing as having a sun. It's just in a collapse, to the negative side. I don't know if I'm making sense. To the negative side. So, the danger only begins when you are close enough to the event horizon. As you approach the event horizon, something called the spaghettification happens. What is spaghettification? You see, let's say you are approaching a black hole, and you are near the center of a black hole. This is the singularity, and this is the event horizon. This is the event horizon. This is the point of no return. What happens here? The gravity here, it is much greater than the gravity outside here. So as you tend to move closer into the center of the black hole, you are going to get stretched, because there is inequality in gravity. So you are going to get stretched and be spaghettified. I don't know if it is a good feeling, because I don't know if it's going to hurt. It's going to crush you. This is the tidal force of stretching. You are going to be stretched. Gravity at your feet will be much stronger than gravity in your head. So you will be stretched into a tiny strand of matter. You are just matter. You just matter. The only thing that is keeping you different from everything else is the consciousness you have. And the moment you stop cultivating that consciousness, it is the moment you are going to die, just basically. And the reason why I hate schooling and I hate authority and people who take away power from you, it is because they don't educate you enough on your importance. They don't educate you enough on who you really are. If you strip away your name, what society has given you, your role, your ethnicity, who are you really? And that is when you start asking those kind of questions. This is when you are going to find out who you really are. So, time also behaves strangely when gravity is involved. According to relativity, which was proposed by Albert Einstein, time slows down near massive objects. Near a black hole, time dilation becomes extreme. Like back then, I think a few weeks ago I told you that time is not obsolete as Newton thought, and Albert Einstein came up with a theory that he said that time is relative to the person and to every place. So time clicks differently in the moon, time clicks differently on Earth, Time clicks differently on the mountains. Time example. If I hold a clock here and another one here, these clocks the time is just the movement over crystal inside a clock over what we tend to call time. That is what we have specified. We have to use it. We have specified. We really wonder yes, that is how painful a black hole is. So you see, to someone who is very distant, to an observer, it will appear that you have risen on the event horizon. I told you the event horizon, this is the point of no return. This is the point which is enclosing the singularity. So, to you, time will feel normal until you cross it. Once you cross it, all paths lead inwards because there's no coming back. That is how afraid you should be. And the next question is, do black holes live forever? For decades, scientists believed black holes were eternal. They believed that they were here from the beginning and until the end they will always be here. Then, in 1970s, Stephen Hawking, one of the great scientists we had, theoretical physicist, proposed something revolutionary. Black holes are not completely black. Due to the quantum effect near the event horizon, black holes slowly emit radiation, now known as the Hawking radiation. Even extremely long periods of time, this radiation causes black holes to lose mass and eventually evaporate. The stellar black holes, these are the biggest black holes we have ever known. This is the process this process will take longer than the current age of the universe. It will take more than 400 billion years in order for the black hole to evaporate through radiation, because we have this Hawking radiation that he discovered in 1970s. So this is one of the greatest minds. He came up with that theory and it really worked, and we are working towards it. But it means that black holes are not permanent. They slow fade. But for us mere mortals who live a few decades, we tend to think that they will be here, they will be here all the entire time. But think about the generation that will be coming, the intelligence life, and the other things that exist in the universe. The universe has existed for billions of years, and we are looking forward to billions and billions of years. What do we actually see when we look at the black hole? In 2019, humanity saw the first real image of a black hole. The image was captured by the Event Horizon Telescope collaboration. It showed a shadow of supermassive black holes in the galaxy Messier 87. In 2022, scientists released an image of Sagittarius A itself, the black hole I told you about, which is in our own galaxy, Milky Way galaxy. These images confirmed predictions made by general relativity over 100 years ago. Einstein was right, even when there was not this Event Horizon Telescope. That is what I'm telling you, that geniuses hit targets that normal people cannot see, and talent is hitting a target that you can see. The information paradox. Okay, now here is where things get deeper. In physics, information cannot be destroyed. If something falls into the black holes and the black hole eventually evaporates, where does the information go? This is something called the black hole information paradox. It sits at the intersection of quantum mechanics and general relativity. The two theories are they both work incredibly well, but do not agree with each other to extreme scales. Solving this paradox may require a full theory of quantum gravity. Some scientists believe black holes may destroy information but encode it in the surface of an event horizon. This idea connects to something called holographic principle. We are going to talk about holographic universe later on. It is one of the ways that we can be able to decode reality. The concept that our three-dimensional universe might fundamentally be described by information of two-dimensional boundary, that possibility changes everything. Could black holes be a gateway to maybe the universe, to another multiverses, to another universe, it may be a gateway into the past or the future? Scientifically, because we really don't understand how gravity and time works, and so we experience time linearly, and we don't know if there's a future or there's a past. It's just a construction of our mind. But if we can actually prove it objectively using space time and gravity, then that will be a big plus for us. So scientifically, black holes are not proven to be wormholes. A wormhole is just a portal that will transform you to another universe or maybe into the past. However, certain solutions to Einstein's equations, I will present these equations sometime back, or sometime in the near future, maybe on another video. But if you are interested, you can click the button down below and the comment section down below and tell me to make a video on the Einstein equations. I will think that video will be another one, so I shouldn't be wasting time trying to talk about it. The Einstein-Ross bridge mathematically allow wormholes. When I talk about Einstein-Ross bridge, I'm talking about this thing. I know you have seen it online. It is like an infinity sign, an 8. So here we have a circle, and then this is something warming up. You see this thing. So they say that this is gravity, and if this is a black hole, you go through this place. Let's say this is a black hole. You go into the event horizon, you are going to come out on the other side of the portal. But I don't think that is scientifically proven. Whether they exist physically or whether they are stable remains very unknown to us scientists, because we have not yet been able to get near to the black hole and try to experience it firsthand. Right now, black holes remain a great mystery. They remain gravitational prisons and not gateways. But physics has surprised us before. Maybe it will surprise us again. We really don't understand how the world works. Why black holes matter? Black holes are not just cosmic monsters. They shape galaxies. Supermassive black holes regulate for star formation through powerful jets and radiation. Without them, galaxies, including our own, may look very different from the way they are right now. They are engines of structure in the universe, and more importantly, they push physics to its limits. At the center of a black hole, our current theories break. Whenever physics breaks, new revolutions are born. I want to finish this by saying that black holes are where gravity becomes extreme. When gravity is very extreme, we have to create a black hole there. We do not create black holes. Maybe we can try to replicate the formation of a black hole in a lab, but it is not physically possible to do that. Where time bends, where space collapses, where our understanding fails. They are not just objects, they are questions. Black holes are just questions. And somewhere inside those questions may lie the key to unifying the laws of the universe. If you can unify the laws of the universe, then we will be able to understand what reality is and what life is and what is the purpose of life. We might say that we have found the purpose of life, but we have not found the absolute purpose of life. If you want more deep science breakdowns like this one, about quantum mechanics, about cosmic evolutions, please subscribe and stay tuned. Don't miss anything, because the universe is not that simple. And if you are watching this video until Sahi, know that you are very different. most people will never get here. Watu wengi hawataifika hapa. Like watu wengi wanapenda kuongelea superficial things like mambo uliamka, umeenda sijui umefanya nini, sijui mimi sisikii kufanya nini, hiyo ni pala, hiyo ni umavi, hizo ndio vitu watu wamejaza kwa akili. But ukianza kuongelea these types of things about black holes, wormholes, how physics works, how the world really works, maybe you are in a certain institution, maybe a mental institution, or maybe a university, umefungiwa pale fulani kwa lab, you're trying to talk with other mad people about these things. Na I know that kuna watu wenye wako curious huko nje, wako curious kama mimi, they want to really understand how the world works. I don't really know, but I'm hoping that you really understand what I'm trying to say. So subscribe down below, hit the subscribe button, like, follow me. So join our community.